Hey, welcome. It is never a bad day for math, so let's get after it here. We got lesson 4.3, functions, part 2. We already understand what a function is. A function is a special type of relation. A relation is a set of ordered pairs, right? And a function is just a special set of ordered pairs in which the domain values are paired with exactly one member of the range value. So what are we going to be doing new with functions? Well, we want to use this new function notation, and we also want to create function tables. The function notation is funky, all right? People get a little confused, a little weirded out by it, but it's really simple. It just doesn't really feel right. So we'll do our best with that. All right, function notation. What is it? It's essentially that you just replace the y that we're used to seeing, especially oftentimes when an equation is in slope-intercept form. All right, we're just going to take out the y. Instead of saying y equals mx plus b, we're going to put a new symbol in. What's that new symbol? A new weird symbol that looks like this. We're going to take out the y and put in this. All right, that's our kind of function symbol here. All right, so here's an example. We take out this y in y equals 2x plus 1, and we put in another symbol that represents essentially the same thing. It just gives us one little insight that a regular y doesn't. It gives us this little x in the parenthesis. Okay, this y doesn't have that, and so it's not as clear what your answers are at different parts of the equation. So anyway, it just gives us a little bit clearer information about the inputs and outputs of a function. Okay, so we're replacing the y with this symbol, and how do we say that? All right, we say f of x. So f of x equals 2x plus 1, or we can say the function of x. Okay, this special function, now we know what a function is, right? We learned about that in our previous lessons. The function of x. All right, y is it? We say y is a function of x. That means y depends on x. When you plug in an x value, you get a special y value. All right, that's what this means. So f of x, or the function of x. All right, so we just replace the y with f of x. Now let's see a little application of this. All right, this is what you'll see as the problems in your textbook, on quizzes, and other assignments. All right, it says find f of negative 3 if f of x equals 2x plus 1. All right, so what happened? They replaced the x with a negative 3. Instead of f of x, they put f of negative 3. Okay, what's this mean? It means that it wants you to find the y value when x is negative 3. All right, how do we do that? I'll show you. All right, here's our example. So what do? We substitute in, they want us to find the y value when x is negative 3. So we put that there. All right, now there's no calculations going on over here with this function symbol. All right, this is just telling us what, it's kind of like, I don't know, placeholder. It's telling you what we're plugging in. So then over here is where all of our calculations are going to happen. All right, when we input negative 3, what are we going to get? All right, so 2 times negative 3 is negative 6. We bring down the 1. Okay, the function when x is negative 3 is equal to negative 6 plus 1 is negative 5. So see how if I just had a y right here, it would just say y equals negative 5. It wouldn't give you the full picture of this ordered pair. So this says the value of the function when x is negative 3 is negative 5. Basically, when I plug in an x, I get a negative 5. It shows your input and your output in one little nice notation there. Okay, so if we were writing it like we did last lesson, right? We've been writing them as ordered pairs. When we plug in a negative 3, we get a negative 5 out. Okay, so this is what it's asking you to do. It's asking you to plug in a -3 and see what you get out once you put it in the equation. All right, let's do a couple examples. All right. You'll notice that these look very similar to the one we just did. This is asking you to find the value of the function when x is 2. If f of x is x minus 4, all right, equals x minus 4. So the value of the function, the y value, is always going to be 4 less than the x value, or the x value minus 4. Okay, let's show the work. So we say the function when x is 2 is equal to 2 minus 4. 2 minus 4 is -2. All right, so f of 2, or the value of this function when x is 2, equals -2. The y value when x is 2 is -2. All right, so that would be 2 comma -2. Your input, your output. All right, your x value is your input, your y value is your output. All right, let's try another one. This is looking for the value, the y value of the function when x is 11. So the y value of the function when x is 11, or the output value when the input is 11, okay, 1/2 of 11 plus 5. We just replace the x's with 11. Now there's no calculations going on over here on the left side. All right, that part's just coming down. Okay, 1/2 of 11 is 5.5 plus 5. So when we substitute in 11, we get a value of 10.5. So in this last part, it shows you when you plug in that, you get out that. So that would be our pair, our ordered pair. Oops. Okay, so this is how we use function notation to get an output value when we plug in a certain input. All right, now we're doing our last little section. We have to make a function table. All right, a function table. You might have done input-output tables or in and out tables when you were in 4th, 5th, 6th grade. All right, so now we're just formalizing it with some new notation. Okay, here is what you will see. Okay, this part up here, it says choose 4 values for x to make a function table for f of x equals x plus 5. So the y values are always equal the x value plus 5. All right, so what do we do here? Well, it says choose 4 values. We can choose 1 million right here if we want. We can choose 5. We can choose -5. We can choose -100. Doesn't matter. Just choose some numbers. So yes, you can actually make it shorter and easier for yourself if you just choose super easy numbers like -1, 0, 1, and 2. It said choose, so why not choose some easy ones? So what do I do? Well, I'm going to do exactly what I did up here. Okay, just in a really abbreviated format. Okay, this is f of -1 equals -1 plus 5. All right, so excuse me, what's my y value? Or should I put my my output value, f of x? Yeah, you can put either y. You could put a y in there, or you could put the f of x. I like y better, but it's just me. All right, so when we input -1, we get the output of, what's -1 plus 5? That would be 4. Okay, when we do the function when x is 0, what's the value of the function when x equals 0? Well, we put in 0 for x this time, and we get an output of 5. When we put a 1 in for x, what's the value of the function? 1 plus 5 is 6. And finally, the 2, when we plug that in for x, the value of this function when x is 2 is 7. All right, there you go. That's a function table. Simple as that. We got our domain values, our input values, our x values. And we have our range values, which are our y values, okay, our f of x values, our output values. All right? So what is it? Summarize here. We choose any numbers we want for the x values. We plug those numbers in to the rule, okay? And whatever we get as our output, we write down as the range values. All right? Here you go. Last problem. You guys can do this. Let's go. Okay, number 5. Okay, choose 4 values for x to complete a function table for f of x equals x minus 7. Okay, so we need 4 values. So what are we going to do? We're going to make our table here. All right, this is our domain and our range, also known as input and output. X, y. We can also put f of x if we want. All right. And then this is our rule. We have our rule right here. F of x equals x minus 7. All right, and then we choose some numbers. What should I choose? I'm going to choose 7. That seems easy to me. 8, 9, and 10. You can choose other values if you want. Anyway, I'm going to plug these in now. So I'm going to do my rule. F of 7 equals 7 minus 7. That's 0. F of 8 equals 8 minus 7, which is 1. F of 9 equals 9 minus 7, which is 2. And f of 10 equals 10 minus 7, which is 3. Okay, so I've made all my pairings. If I wrote them in as ordered pairs, I'd get 7, 0, right? 8, 1, 9, 2, and 10, 3. It's a relation. It's actually a special type of relation. It's a function, and it's actually a special type of function. It's a linear function, okay? Because if I were to put these on a graph, they would make a straight line. And I could also find a constant rate of change if I were to do this. 1 and 1, 1 and 1, 1 and 1. The ratio of the change in y to the change in x, the rise over run, is constant. All right, I threw all that stuff about linear relationships in for free as an extra bonus to you. You're welcome. All right. Never a bad day for math. Mr. Woodworth, out.